This second example on here, harder than the first example. The first example is considered the easiest one because you had the equation given to you. This one, there's no equation, so we have to create a graph from the information that we're given, use the graph that we created to find that function. So the only information is we have a Ferris wheel, has a radius of 15 meters, and rotates once every 20 seconds. Passengers start at the bottom of the Ferris wheel, which is 1 meter above the ground. So we have to take that information and somehow put it into a graph. So to help us, we'll try to draw a picture here. Here's my Ferris wheel. Woo, we have nice little chairs on there. Oh, those chairs look backwards. There we go, maybe this way. Oh yeah. Everybody loves a Ferris wheel. Draw people. Look at this. Smiling. Oh, they're having so much fun.
Can you make like someone falling off and like splat this dead bodies on the floor?
This person is going to get kicked off pretty soon. All right. There's our people on the Ferris wheel.
Exactly. Yeah, that's a good one.
And so, right beside this, because I've got the picture here, I'm going to draw my graph right beside it to sort of get a picture of what's happening. So the question tells us that there's this Ferris wheel. It has a radius of 15 meters, so I know that this distance right here is 15 meters. You get on at the bottom, so I'm going to graph this. I'm going to have my height along my y-axis and time along my x-axis. My height is in meters. My time is in, what is seconds. Where does a person get on? Bottom, right? It's very hard to get onto the top of a Ferris wheel. I don't know if you've ever tried, but yes, not a good idea. So you get on here, time 0, that person is 1 meter above the ground. Can you tell me another time and where they will be? So, given this information, you get on at 1 meter above the ground. So at time 0, you're at 1 meter above the ground. At some other time, you'll be 16 meters above the ground. What time would that be? Okay. So, but that's good because 16 is going to be important. Is that the highest you're ever going to get? No. No. Why not? 16 would be right here in the middle. That's where I drew the 16, right? What's this highest point where this guy is right now? Super happy, tongue hanging out, and everything. How high is that? 32. Not 32. 31. Why is that 31? Well, our radius of our Ferris wheel is 15, right? So if the middle is at 16, it would go up another 15 from there. And down 15 from there. Yes.
So for the 16, does it start from the bottom, like, or it starts from that?
The 16 would match up with right at the middle of this Ferris wheel. You start at 1 meter, so here the starting point. That's why this is up a little bit here. Here's the ground. Yeah, it's not good if your Ferris wheel goes into the ground. It's not very fun when you're going around. So we've got our heights now. We just need to tell me what time. So here we will draw a super happy face. Someone really enjoying their time. There we go. This is where they're at, oh, there's another one. Here they are, time 0. How long does it take them to get back there? 20 seconds. So we can put on here, I know that at 20 seconds, I'm going to be all the way around. How long will it take to get to the top? 10 seconds. So if we cut this in half, we'll be at 10 seconds. What about here? Starting here, how long would it take to get there? If it takes 10 seconds to get here, how long? Oh, 5 seconds, yes. And then, yes, on the other side too. Now, can you see that that makes sine or cos graph? We probably shouldn't put the arrow on this end because you can't go back in time, but that's the idea. So we take the situation, we think about the situation, we create a graph, and it makes a sine graph. Now we have to come up with an equation. So we're going to use our skills of how do we take a graph and make an equation from that graph. Oh, there's this happy guy. Well, can you tell me these three values? The D, the A, and the B. D is 16, that's right in the middle. Perfect. What's your A value? 15, that's your radius. That's your amplitude. And what's our B value going to be? Close, but remember the B value is connected with our period. So we have that our period is always 2 pi divided by the B value, and our B value is always 2 pi divided by our period. What's the period of this graph? It only takes 1 second to repeat itself. Period is how long it takes to repeat itself? 20 seconds. And so our B value will be 2 pi over 20. You could reduce that, but I actually like keeping it as 2 pi over 20 because then you really can see, oh, the period's 20. If I reduce it to pi over 10, it's not as obvious from just looking at it that the period is 20. So now that you have that, we could write an equation. And it didn't say in this one that we had to do sine or cos. So let's do one of each. If we are doing one graph with sine, one graph with cos, the amplitude is going to be 15 for both of them. One will be sine, one will be cos. The B value, 2 pi over 20, will be the same for both of them. And the center line at plus 16 is the same for both of them. Where does a sine graph start? In the middle going up. So at what time are we at the middle going up? We're not at the middle here at 0. So here's our middle. Can you see that right here at this point? We're at the middle going up. So that would be a shift of 5 units to the right. Where does a cos graph start? At the top. So cos graph starts at a maximum. That's here. That's 10 seconds to the right. So we could go minus 10. In this graph in particular, probably the most preferred graph of all of them, or most preferred equation, would be this one. Why do you think someone would like this one? I'll leave space. What's nice about the negative cos graph? It starts at the bottom, which is starting at 0. So I wouldn't even have to add anything in here if I didn't want to. I can go plus 0. It's not wrong to write plus 0. But that would be another graph. Yes? in figuring out the C value, because you figure out DAB first and that stays the same, but the thing that changes is your C value. For a sine graph, you're looking for the middle going up. Because if you think about your basic sine graph, it starts in the middle going up. When you think about your basic cos graph, it starts at the maximum. And so that's the key point that we're looking for when we're looking for our starting point. If a sine graph normally starts in the middle going up, well, that happens here 5 to the right. So then we know that our phase shift is a horizontal translation 5 to the right. How does that show up in an equation? That shows up as a -5. Cos graph starts at a maximum. First maximum is 10 to the right. So we could show that as a -10. But we also notice that if a cos graph starts at a minimum, that would be a negative cos graph. Where would a negative sine graph start? Because that's one we didn't do. But if we did have to make a negative sine graph, middle going down. So remember that that negative is a flip. It's a flip over the x-axis. And so a sine graph, if you imagine a regular sine graph being flipped over your x-axis, it still starts in the middle, but it goes down. So now that we have this information, I'd like you to take out your graphing calculator and get that picture on there. Now, it doesn't matter which equation you choose, so I'm going to go to y equals here. I'm going to clear out what I had before. I'm going to use the negative one so I don't have to shift things. Cos 2 pi, and you can use the fraction button in here as well if you'd like. So 2 pi over 20 plus 16. Now when I push enter right away here and push graph, I have my old window set up, which isn't a bad window, but doesn't quite go high enough. And it seems to never come back down. Oh, there it is. So I'm going to go back to my window, thinking about the graph that I already sketched. My x max, I want to go a little bit past 20, so maybe I'll go to 25. My scale seems to be going by 5s. That will be nice. Y min, it went up to 31, so I'm going to go up to 35 and graph it now, and it shows up. Whew, got a little scary, almost hit the ground there. So there's our graph. Now, in part B, it says estimate the height after 22 seconds. For this, we don't need our calculator. What they're wanting you to do is look at your graph and say, if you went to 22 seconds, which would be here, 22 seconds, what would you estimate the height to be? Let's put down a couple numbers. What do you think the height should be? About About 4 meters? That look about right? Okay. How many people think it's going to be above 4 meters? How many people are going to think it's going to be below 4 meters? Or how many people think it's going to be exactly 4 meters? Okay. So if we wanted to find out exactly what it is at 22 seconds, well, since we've got it into our calculator, we can go second calculate. Trace has a bunch of things. Number 1 says a value. What a value lets you do is plug in any number you want, 22, and figure out what it is. 3.86. Oh, yeah, that's like practically 4 meters. So really, really close. So we can get an actual value. And the nice thing about your calculator is once you have one value, once you've done that once, you can keep putting different numbers in just to check, oh, that's where it's at 15. What about at 12? There it's at 12. and you can type different things. From your graph as well, something that's sometimes useful is your table. So if you go second graph, you get a table. And it has all the values going down. So if we kept going down, we'd eventually get to 22, and we could find our answer at 3.84 meters that way. Okay? I once had a student in class decide how long, if I spent all class just pushing the down button, how far could I get? Like, this is really fun stuff to do in math class, right? So everything was good. He got to end of class. He was like at 5,000 something. And then we did another question, and he wanted it to get back to 0, right? So if that ever does happen to you, I let him go up for a long time. And then I told him, you can go second table set. Where do you want to start? Right now it's starting at 18. You can just go 0 and start it back at 0 again. And life's easy. Does that mean not to let him know? Now, estimate at what time it's going to be 20 meters above the ground. So if we go on here again and we look at 20 meters, 20 would be about here and went across. What times do you think you'll hit 20 meters? Well, that looks like there's more than one in the first revolution. 7 and 13 seem reasonable of when you'd hit 20? So let's guess 7 seconds and 13 seconds. Now, if you wanted to get the exact values from your graphing calculator, when you want to find an x value, you can go second calculate and value. When you know a y value, what you need to do is go to y equals and type that y value in. So 20. When you graph it, that line will draw, and this is where we can use the intersect. So I can go second calculate, number 5, intersection 1, 2, 3, guess, 14.14. So this one on the right was 14.14. Without your calculator, can you tell me the one on the left? 5 point, close. Even more, I want one more decimal place.
2, 3, 4, 5.
6. 5.86. How did we do that? If I know this one's 14.14, how did I know that one was 5.86 without my calculator? Maybe I'm just lying. Maybe we're wrong. Maybe we should check, right? Second, calculate, intersection, da 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 da. 5.86. So how did we know? If I knew this one was 14.14, how did I know this one was 5.86? Because I've been a teacher and I probably memorized these answers before class. Oh, you've got me figured out. That's what I do all night. Spend hours memorizing all the numbers.
You never know. You know what people
Yeah,
have different
I know.
hobbies, you
Yeah. Yeah, you are judging me. But you're trying to be nice. It's symmetry. Here's 10. Right in the middle, it's 4.14 that way. It'll be 4.14 that way. The sine and cos curves are very symmetrical. All right, let's get to our last example, tides. World's highest tides, Bay of Fundy, and they're periodic in nature. So that means they follow sine and cosine curves. Again, this one we're going to have to draw a picture. So the maximum depth of 8 meters is measured at 4:30 a.m. 6 hours and 12 minutes later at 10:42, a minimum depth of 2 meters is reached. So I'm going to draw a picture of this. What should I label? what will my y-axis be? And what will my x-axis be? Depth, yes. And the x will be time. Okay. So now that we've got that, time is in hours, and depth is in meters. Any important depths you would like to put on your y-axis? 8 and 2. So 2, 4, 6, 8. Those are important because those are going to be our minimum and our maximum values. When is it at 2? It's at 2 at 10:42, and it's at 8 at 4:30. So if I put it 4:30, what do you think I should mark along here for 4:30? 4.3? 4.8? 4.5. Okay? That was the easy one. 4:30 is 4.5. It's a little bit tricky to do math with minutes and hours, so we have to sort of only work in hours, and 4:30 would be 4.5. And at that point, it's at its maximum at 8. 6 hours and 12 minutes later. That, I'm going to measure that to be about there. It's at the minimum at 2. I need you to tell me, what do I put under that ticky mark? $4.7. And how do we know it's exactly 4.7? Is that an estimate or is that an exact? It's going to be 10:42. So how do we figure out what? Like if it is 10.7, how do we know that that's exact?
Check the value.
So how do you check 1042 on your calculator? Type in 1042 and it's like got Siri in it and she's go, oh, 10.7. 42 out of 60 is equal to 0.7. And so you're saying because of that, this should be 10.7. Now, why would we do 42 out of 60? Because there's 60 minutes in an hour. And so this is the fraction of the hour. You did that with 30, but it was so easy because it was half an hour, right? 42 minutes, not as easy. And so we have those 2 points. And that's all you need. We have enough information to create our graph. In fact, it's going to look like this and keep on going. So with those 2 points, how is that enough information, you know, if we're doing DAB, how do we know our D value? With just those 2 pieces of information. The average of 8 and 2, right? You got 8% on your first quiz in this unit, 2% on your second quiz. Your average is 5%. And you need some extra help, right? Okay. Right, here's our average at 5. So now we know that our D value is 5. What's our amplitude? 3. What's our B value? Well, first of all, what's our period on this graph? Why do we have enough information with just our maximum and our minimum that we can tell what the period is? So if we know that this distance here is 6.2, that's going to be half of your period. So your period is going to be 12.4. And then your B value is going to be 2 pi over 12.4. Well, if it takes 6.2 to go from 4.5 to 10.7, okay? That's how much it takes to go from the maximum down to the minimum. Because it's symmetrical, it's going to do, to get back up to here again, it's going to take another 6.2, and that'll be 12.4. Now this question said find one with sine, one with cosine. So we can write out two equations. The A is going to be 3 for both the sine graph and the cosine graph. Your B value is 2 pi over 12.4 for both of them. And your D value plus 5 is also the same for both of them. What are we going to do to finish the sine one? Where does a sine graph start? In the middle going up. That doesn't match with any of our points yet. Can you see that there would be an in the middle going up here and also another one here? How are we going to find out those values? Yes? Okay, so if I make a line in the middle here, right, that's where this is going to be. How much is that going to be? Okay, yeah. How much is it between here and here? $3.1, right? And this will go up to 7.6. So this one back here would be going back 3.1 to 1.4. And here you could go up another 3.1 to 13.8. What would 13.8 mean? What time would that be? Like 150-ish? 148? Because 13 is past 12 o'clock. So it'll be in the afternoon.
Don't ask me.
So if we wanted to choose one of those points, we could choose either one. Usually we do pick the one that is nearest the x-axis, so it would be a shift of 1.4 to the right. If you picked a cos graph, and I usually find making the cos equation easier. It's easier to find maximums and minimums than center line going up or center line going down. So where's our first maximum? 4.5 to the right minus 4.5. Part B says to estimate it at 130. So if I go here, 130 would be 13.5. That's going to be under 5. I guess I would, we guessed 4 before and it was so close, so 4 meters is going to be my estimate again. If you wanted to find it out exactly, you'd have to type this back into your calculator to figure that out. Any questions?